Jai Hind everyone. I am Achintya Pandey, Ajay Assistant Professor in IT Department at Ajay Kumar Garg Engineering College. Today I am going to discuss about the data structure. Okay, basically I am going to explore the foundation of data structure, especially the linear data structure, array and linked list. We will also see the abstract data type and little bit some operation which is performed on the data structure. So the objective is to explore the mainly foundation of data structure, abstract data structure, and kind of linear data structure, especially array and linked list. Okay, these all are the topic which we will discuss during the time. Okay, introduction, definitions, classification, array and linked list, abstract data types, and little bit double linked list. Okay, so what is data structure? So data structure is basically it is a mathematical and logical arrangement of data, right? How the data is going to store, how the data is going to organize in memory, right? How it is going to, either it is in form of linear, sequential, or it is hierarchical, or how it is going to organize. So that is called data structure. So data structure is basically arrangement of data. Okay, so it is a particular way of storing and organizing data in a computer so that it can be used efficiently. Okay, so we have different kind of data structures are suited to different kinds of application. What kinds of applications are there? We take suitable data structures to manage, to store, to organize that data structure, right? So storing and retrieving can be carried out on data stored in both main memory as well as in secondary memory. Okay, these are some classification of data structure. So if we just going to classify the data structures, I mean organization of data. So this could be in the form of type of, what type of data structure. So we can categorize into primitive and non-primitive. Primitive means basic data structure available, like we can say int, float, character, inbuilt data structure. Primitive means which is derived from primitive data structure. We can say like stack, we can say like kind of a tree, okay, which is derived from int, float, char, some kind, right? Then we have one classification, homogeneous and heterogeneous data structure. So in homogeneous data structure, we would have, I mean, same type of, okay, like array is a homogeneous. We are going to store so many data of the same type, right? Like suppose if you are going to store marks of 100 students, so all marks are integers, right? So that is called homogeneous. Heterogeneous means like a structure is a heterogeneous. Heterogeneous means different kind of data grouped together. So there could be the structure, or even in C++ we can say class. Class are the heterogeneous. Okay. Then we have depending on the memory allocation, whether the memory is going to allocate at compile time or run time, the data structure could be classified into static and dynamic. Static data structure means the memory for those data are is going to allocate at compile time before run time, right? And if the that is called static data structure. And dynamic data structure, if memory is allocated at the time of runtime, then this would become the dynamic. So there are functions for dynamic memory allocation like malloc, alloc, realloc, and all that. Okay. Then we have linear and non-linear. Linear means maintain a linear relationship between elements. Like we can say have array. Okay. No, and non-linear means which is non-linear, kind of hierarchical, like tree graph. This could be non-linear data structure, hierarchical data structures. Okay, so these all are various depending on various criteria. These all are different classification of data structure: primitive, non-primitive, homogeneous, heterogeneous, static, dynamic, linear as well, non-linear. Okay. Then the comes abstract data type. Okay, what is abstract data type? So the concept, general concept is, see, problem solving with a computers means we are going to process the data. So to process the data, we need to define the data type, right? What type of data, it is integer, float, character, boolean, and what, and the operation which is going to perform on those data. Okay, so the definition of the data type, right? The definition of the data type and the definition of the operation which is applied on that data is part of the abstract data type. Okay, so abstract data is nothing but, I mean, what is the definition of those data, I mean those data type, as well as the operation which could be performed on those data type. Okay, so how we going to, I mean, settle down, that comes under the abstract data type. Okay, so the user of an ADT, means abstract data type, needs only to know that a set of operations are available for the data type, but does not need to know how they are applied. Okay, means we fix we do I mean, implementation detail is free from users. Operations could be performed, but how it is going to perform, that is not bothered by the user. Okay, so several simple editors such as integer, real, character, pointer, and so on have been implemented and are available for use in most languages. Okay, I mean high level language. Okay, before exploring, I mean, few data structure, let's see the data types. So a data type is characterized by a set of values, a data representation which is common to, I mean, common to all these value, and a set of operation which can be applied uniformly to all these values. So that another data type. Like if we say the integer data types. Okay, so integer data type will take only integer value, and how this integer value could be represented, what operation on integer data could be performed. Okay, so mainly data types, any type of data types will have set of value and data representations and a set of operations which is performed on those data types. So these all are the primitive data type, mean basic data types. Boolean, I mean true or false, char for character, byte, integer. Okay, float and double for real number. Each primitive data type has three things: a set of value, data representation, as well as the set of operations. Okay, so now we can define what is abstract data type. So in computer science, an abstract data type is a mathematical model for a certain class of data structure that have similar behavior. Okay, and abstract data type is defined indirectly only by the operation that may be performed on it and by mathematical constraint on the effects and possibly cost, I mean like time complexity, space complexity of those operations. Okay, so an ADT, abstract data type, may be implemented by a specific data type or data structure in many ways and many programming languages, or even it could be described in formal specification language. An abstract stack could be defined by three operations. Like in a stack, we have three push operation, pop operation, and push means we are going to insert element. So how you are going to insert element? So and what kind of operations? So that operation is called push operation, and in stack we do last in first out. The element which come last, okay, that will be popped out first. Okay, so push that insert some data item onto the structure, pop that extract means remove an item from it, and peek that allow data on top of the structure to be examined without removal, just to print what is the top value. So we can perform operation peek. Okay, so abstract data type is a set of operation. It is a mathematical abstraction and no implementation detail. Means implementation detail is hidden from the user's perspective. Users should not be bothered about how the operation are going to perform on the data type. So example are list, set, graph, stacks, all the example of abstract data type along with their operations. Okay. Now the list AD. List is basically collection of elements, collection of data values, and data value could be of similar type, same type, data value could be of different types. Okay, so list could be implemented either by using array or even by the linked list. Okay, so the list is an order sequence of data item called element. Like we have A1, A2 and AN is a list of size n. Size and empty list will be 0. Like any particular item, if we say AI plus 1, so that succeed AI before. AI comes before AI plus 1. So AI plus 1 succeed AI, AI minus precedes AI, right? So position of AI is particular ith. Like if we start from 1, say there are 20 items, if we say 4th item, so it will be 4. So the suffix value shows the position. So first element is called head and last element is called tail. Okay, these all are the various operations. So if any data structure is basically arrangements of data. Okay, so those arrangements or any particular arrangements will require or would be have some operations. So these all are the some operation on the list, like make empty, you can print empty list, you can write the function corresponding code in any particular language and you can perform these operations. Like make empty, this will simply remove all the element and will make the list empty. Okay, print list, find, you can find, search, sequential search as any kind of search, find kth element, insert, you can insert any element. Okay, say either in the beginning or last or in between. Okay, so these all are various operations which can be performed on the list. Okay, delete, next and previous. Like if we have list of say 5 element 34, 12, 52, 16, 20. So find 52 means what is the location of 52 in that list? Yes, it is in the third. This is the third position. So if we just perform operation find operation, it will give the location of 52. Find 52, that will simply give the location of 52 in that list. So it is in third position. Similarly, you can insert, say if you are going to insert 20 at the location 4th. So you can do this. This is if we start from 1, then 2, then 3, then you can insert depending on what type of data structures. If it is linear, then simply that particular position is to be emptied and there you can insert. Okay, similarly delete and find kth. Okay, so list can be implemented using array or even the linked list or even cursor. Cursor is basically linked list using array, that is called cursor. Okay, so list is basically collection of elements. Okay, linear collection is sometimes you can say. So that could be implemented either by the array or by the linked list. So array is also what is array? Array is a basic data structure. I mean very simple data structure. Okay, linear kind of data structure where homogeneous data, data of same type is going to be stored. Okay, so it is a static data structure. Static data structure means the memory will be allocated during the at the compile time, just before the run time. Okay, that is called static data structure. Once and the size will be fixed, reserve. If you are going to say give size 30, even you are going to store only say 5 elements, so it will store the size of 30, right? So before runtime, compile time, memory is going to allocate in the array. So array is a static data structure that represents a collection of fixed number of homogeneous data item. Okay, homogeneous means data of same type, like all integer or even all real number or even all characters. So that is called homogeneous. So a fixed size index sequence of elements all of same time. The individual elements are typically stored in consecutive memory locations. Okay, consecutive means one after another. Okay, like if every element takes 2 bytes, then the next element will have after 2 bytes. Okay, so the length of array is determined when the array is created and cannot be changed. Okay, different types of array. We have one dimensional array like linear array. We could have multi-dimensional array like 2D, 3D and all. Okay, so depending on, I mean, logical, you can make 2D or 3D. Okay, like if you are going to store in kind of in form of matrix, we can create 2D array. Static array means the compiler determine how memory will be allocated for the array. Dynamic array memory allocation takes place during execution runtime. Okay, so this is the some syntax. If, say we have array like array name. So this is the syntax. Element type. What type? Suppose if it is integer, then you can say int, float, or char, or something like that. Okay. So we have B whose size is 5. So you can store 5 element at most. Okay, right. So the size could be determined during the compile time. Okay, say here this is a function display with take array, okay, and a single value, num value. Okay, so you can print like that. This is a simple function in C or C++. Okay, so here if an array has the capacity say 10 and just have elements say 4 element, so all these remaining block will be, I mean, simply it will be wasted. So you can see here list implemented using array. This, I mean, total capacity of this is 10. We have 10, 0, 1, 2, 3, I mean up to 9. So capacity 9. Even we have 4 elements. Okay, rest of the, I mean, block will be simply wasted. Okay, these all are the operations on list. We will consider only few operation and not all operation on list. Let us consider insert. There are two possibility: ordered list or list could be ordered. I mean, order means say in ascending order. Okay, so the element, any element, any random element will be placed in particular order, not just I mean randomly. Okay, say increasing order, so every element will be will be in the order of ascending order. Okay, like see, this is an array. So 1, 3, 6, 7, 10. I mean, ordered is, we can say in increasing order, ascending order. I mean order. So if you are going to insert say 4, so how you are going to insert? So 4 will comes. I mean after 3 and before 6. So the position of 4th in this array will be here. So how you can insert these 4 element? So from this point we make shift. I mean we shift every element just by 1. So 10 will be shifted. So this will be empty. Then 7 will be shifted by 1. So here, and last 6 will be shifted to here. So this position will be empty, and we have made an, I mean, empty space. There you can insert 4. So this is the logic of say inserting any element into an ordered list. Okay, into an array. So by this way, simply you can insert any element into the ordered list. Okay. So there are certain disadvantages of array, because one disadvantage is we make reserve for the space during the compile time. So this is the simple advantage. I mean, or you can say the array could have wastage of spaces, right? So need to define a size of array. So high overestimate, waste of space will be I mean more, because if we don't, we can't predict how many elements are there. We would have to, I mean, reserve some sizes, some size. So even elements are not that much. Okay, so simply they would be the wasted. The space will be wasted. Okay, so insertion and deletion is very slow. Why it is slow? Because if you are going to insert so at particular positions, so how you can do? Simply we would have to shift all those elements. Okay, say there is an you want to insert at ith position. So from ith you need to, I mean, shift every element just by 1. Then ith will be empty, and then you can do. So this will take a quite considerable time. Okay. So need to move elements of the list. So that's why insertion and deletion is very slow. Redundant memory space, it is difficult to estimate the size of array. So these all are some disadvantages of arrays. Linked list. Linked list is simply collection of various nodes, and there is no restriction that every element will be just placed in consecutives. Wherever you are going to, uh, insert, wherever you want to insert an element into a node, you can have your locations, you can give the location, and they could be stored. So linked list is basically collection of nodes, and every node will be have two value. One is every node has two fields. One has in the first field it will have the value, and second will have the address of the second node. Okay. So by this is the logical arrangement, like first node. Okay, this location is 350, and say 500 is what location of the second node. So there you can place like this. Okay, so 500 means location of next node. So there you can put those values. So okay, so linked list could be represented like this. Linked list is basically collection of nodes, and nodes will have two value. One is nodes have two field. First field denote the value, and second field denote the address of the next node. That's all. Okay. So series of nodes not adjacent in memory contain the element and a pointer to a node. Pointer will have the address of the next node containing its successor. So avoid the linear cost of insertion and deletions. Okay. Singly linked list. This is the start pointer. Start will have the address of the first node. Sometimes it is denoted as a header node, and next like this. So you can represent a singly linked list like this. The last node would not have any. The field of next pointer in the last node will have value null because there will be no further node. So at next pointer in the last node will have value null. That's so the end of the list. Okay. Similarly, double linked list. Double links means if you are going to backtrack. Okay, so you cannot do in single linked list. Okay, so in doubly linked list you can define that it is collection of so many nodes, and every node will have two value. One has the every node has three value. Three fields. First field will have the address of its predecessor node. Second field will have the value field. What is the value it is going to be stored. As third field will have the address of the next node. So every node will have the location of its successor as well as predecessor node. So it will have three field in the double linked list. Okay. These are, so advantage of using linked list is need to know where the first node is. The rest of the nodes can be accessed. Only there will we have just the address of the first node. If we have the address of the first node, then you can simply track to any node. Okay. So no need to move the element in the list for insertion and deletion operation. You can have simply address of that particular node, and there you can fill the value, and by making the adjustment of pointer, the value of next and all, and there by that way you can do these operations. Okay. So in linked list the advantage is memory could not be wasted. Okay. We need not to store in advance. Okay. Reserve space in advance. So memory wastage will be resolved. Okay. These are the pros and cons of arrays and linked lists. Arrays directly supported by C provide random access, and this is a site determined at compile time. Inserting and deleting element is time consuming. Because why it is time consuming? Because we would have to shift the element. where we are going to insert just by one. Okay, so by shifting will take some time, and so it will have time consuming. Okay, linked list pros and cons. The pros is size determined during runtime. Okay, this is the advantage because we do not bother whatever the size that would be determined at runtime. Inserting and deleting elements is quick. Okay, because we are not going to shift elements in linked list. Simply we would know the address, and there we could put the value. I mean, just by adjusting the next pointer field and all that, right? Cons में I mean no random access. User must provide programming support. Okay, so implementation is I mean little complex than the arrays, but memory wastage will be no. Okay. These are a few application of list. List can be used to store the record sequentially for creation of stacks and queue, for polynomial handling. I mean operations like ax square plus bx plus c kind of operation. A list can be used. Okay. So to maintain the sequence of operation, for do or undo in software, to keep track of the history of website visited, we can use the list. Okay. These are some advantages. Why doubly linked list? Doubly link. So given only the pointer location, we cannot access its predecessor in the list. So another task that is difficult to perform on a linear link is traversing the list in reverse. If you are going, so if you wish to, I mean traverse the list in backward direction, we cannot do in single linked list, but by using double linked list you can. Okay, so double linked list will have each node is linked to both its successor as well as predecessor. So you can, I mean, move or track in both direction, either forward or backward at any from any particular node. Okay, so in such a case where we need to access the node that precede a given node, a doubly linked list is useful. Okay, like here we can see every node will have 3 field. In the center we have the value, and rest 2 will have the address of its backward and address of the forward node. Okay. So in a doubly linked list, the nodes are linked in both directions. Each node of a doubly linked list contain 3 parts. Info part is basically the data stored in the node. Next is the pointer would have the address of the next node, and back is the pointer that contain the address of its preceding node. Okay. Okay. So operation on doubly link, like in single link we can perform find and all operation. Okay, which could perform on the signal. Single linked list. So similarly, you can perform on the double linked list too. Okay, so the algorithm for insertion and deletion operation and doubly linked lists are somewhat more complicated because we are going to handle one more pointer additional. Okay, so including pointers, the implementation will be little complex than just by using array and all. Okay, there are more pointer to keep track in doubly linked list, and by that the implementation is little complex as comparison to single linked list. Okay, so that's all about a simple overview, foundation of data structure like array, linked list, abstract data type, and all those. Okay, so in a nutshell, data structure is basically arrangements of data. Arrangement could be in the form of linear, arrangement could be in the form of non-linear. We have seen the classification of data structures. Okay, depending on type, what type of data structure, primitive or non-primitive, and depending on the storage, we would have homogeneous, heterogeneous. So depending on the storage, could be static or dynamic. Similarly, type, either homogeneous or heterogeneous. So these all are various types. Okay, so that's all about. Thank you very much.